Interceptors. So what I did was I kind of broke this down, and we'll go through why interceptors are used, our kind of standard design features. We'll go through the models, and then we'll go out in the warehouse and look at, we have an oil interceptor, a grease interceptor, just to get you familiar with visually what it looks like, and so any questions come up or anything like that, hopefully that'll help out. First off, purpose interceptors. Page 2, you can see those were two pieces of cut pipe that were taken out of a drain line. You can see how much it clogs. When the grease was liquefied, it's flowing through. It looks like it's fine just going down the drain, but eventually that's going to cool somewhere, start to solidify, stick to the pipe walls, and just keep building and building until it creates a blockage. So the purpose of an interceptor is to separate and store materials from the water passing through it. They're normally installed on drain lines coming from a device that could have, whether it's oil or grease, solids, sediment, sand, that need to be removed from that prior to entering the public drain system. Most of the time, this is all regulated by local codes and guidelines because the city doesn't want to have to pay for constantly having to go and clean all the drain lines and unclog everything like that. So it's usually mandated and dictated by local codes and guidelines. Some of the basic components of the interceptor, I got the illustration on page 3, which is taken right out of the book, page 177. Our body and lids are acid resistant, epoxy coated inside and out. Some companies or competitors, they'll use a different type of coating on the outside, something not as durable. We epoxy coated both on the inside and out. Our lids are made of 7-gauge diamond plate mild steel. You've seen those out there. I'm sure we'll take a look when we go out there. The HD option, those are the same 7-gauge lids, but they have reinforced angle iron underneath to give it more support and strength. The lid bolts, those are called the My bolts. Those are 5/8 11. That's the thread pattern on them. Flange bolts with a neoprene washer. We'll see them out there when we go take a look. Then there's what's called the MIFAB that goes over the bolt head when it's installed. Eliminates a tripping hazard. The crossbars, those go across the inside of the interceptor that the lid bolts down to, or the bolt bolts down to hold the lid down. Those are held into the interceptor. There's crossbar holders, brackets, and then there's 2 cotter pins on each one, so it can't pivot in there. On the crossbars, the nuts are welded on the top of them. That's in case the weld rusts or anything, you can still get the lid off. It's probably easier to explain out there, but if you have the crossbar and the nuts underneath and the bolts going through, if that nut just starts spinning, it's all locked in place. You can never get in there without, cutting up the lid or anything like that. So if it does rust out or, strips, you're able to still lift the whole unit out and replace what needs to be replaced. The bodies of our interceptors, they're made with 1/2-inch feet on the bottom. So the inlet and outlet side, they actually are made longer and come down, and you can see an illustration there. So what that does is allows the interceptor, when it's sitting on a floor, to have a gap underneath the interceptor. So moisture and condensation as it building up reduces a lot of corrosion, or chances of corrosion, because you have the air gap allowing whatever water spills or gets under there to properly dry. Sewer gas stopper and deep seal trap, that's located on the inside of the interceptor on the outlet side. The deep seal trap, what it does is it'll take water from the bottom, where it's normally the cleanest. Your grease and oils will rise, we'll talk about that. And then the sewer gas stopper, what it does, it creates a barrier for the drain line, so any sewer gas smells will not enter into the interceptor. We've had some issues where people call and say, oh, I'm getting a bad smell coming from the Interceptor. Well, what happens on the inlet side of the Interceptor, between the sink and the Interceptor, they won't put a P-trap. So they're not getting sewer gas smell coming from the drain lines, but what they're getting is the smell of all the particles and grease and oils that are in the Interceptor. So that's why what our instructions we show, install a trap in between the sink and the Interceptor so you don't get that smell. And there's some illustrations we'll look at later on that. Internal baffles. The internal baffle for like the standard grease interceptor, what it's used is to direct the path of the water entering the Interceptor. So the water isn't flushing right through the Interceptor. It kind of stops it and allows the Interceptor to work properly. Flow controls. Either Interceptor will have an internal or external flow control. What the flow control does is it regulates the amount of flow going through into the Interceptor. We'll look at the internal and external ones later. So these are just some basic designs on most of our standard type of interceptors. And when you get into special stuff, custom, like a rare, used, specific application interceptors, it'll be a little, might have some different options, but this is, pretty much the standard stuff that you'll find in an interceptor. Any questions on anything? Or? First one we're going to look at is grease interceptors. The purpose of a grease interceptor is to trap and store suspended grease from the water passing through it. They're usually connected to kitchen sinks, floor drains, usually located in hotels, restaurants, institutions. MIFAB's grease interceptors operate on the principle of separation by flotation. So you can see the illustration there. We'll talk about kind of the function of it. The wastewater enters the interceptor by hitting the baffle. So that's the baffle we were talking about. So as the water enters, it hits that, and what that does is that calms the water down as it's hitting the interceptor. It's not flowing through, disturbing all the water and grease that's separating in the main body of the interceptor. So the main part, so pretty much in between your baffle and your deep seal trap on that illustration, that's just a large holding area. And when the water and grease and oils enter that, that's the time that's used to allow all the grease and oil to separate. On the bottom, you'll see there's that sludge stop. Most of the grease and oil interceptors have that. So what that does is any type of sediment or debris that will sink in water, this will stop it from going to the deep seal trap and clogging that up. So interceptors are always, when they're put into service, they're always filled with water because that starts the holding area. So as water enters, what I tried to do here with the illustration is you have the blue, the water, the brown is like your grease and oils. So as it's come in and it's, grease is, liquefied with the water, the oils with the water, as it comes in, it hits that baffle and that'll calm it down, forcing most of the water to enter underneath the baffle. And when that happens, it allows all that area inside the interceptor to be real calm, and as that oil or the grease cools and the oil separates, it'll rise to the top. Oil and grease are less dense than water, so they sit on top of water. So that's the whole MIFAB's interceptor principles by separation. And then once it separates, when more water comes in, the water level in the interceptor is always going to remain constant. So anything that has to be pushed out of the outlet will come from the bottom all the way at the outlet corner where it's the cleanest water. Most interceptors, any PDI ones we have, those all operate on 95% efficiency. So they test them in the lab, and they'll dump so much oil and grease, and after every cycle, they'll test it, and it needs to accumulate 95% of all the oil and grease that's going through the drain system. So then talking about flow controls, if you look on page 180, do you have any questions on that interceptor layout? I think it all makes sense. Page 180 has some information on the flow control fittings. External flow control, which is shown on page 180, have the same connection as supplied on the Interceptor, with an internal orifice plate calibrated to allow the proper flow into the Interceptor. When we get into the models, we'll see some of the sizes and what their differences are. The external flow control is to be installed prior to the Interceptor. You want to control the flow of what's going into the Interceptor, not what's coming out of it. If you do that, it could allow the Interceptor to back up because you're pushing more water in than it's allowed to flow out. The external flow controls also have a vent connection that's to be connected to the vent system, the drain lines. We looked at that before. I don't know if you guys remember the house where it had the drain lines and it had all the vent system. The vent connection allows air to enter the drain pipe and creates a smoother flow of the drain water as it enters the Interceptor. So what it does is you're allowing the air and the water to keep a smooth volume so the water flows in a lot easier. Interceptors that have an internal flow control, those are located on the inside of the Interceptor at the inlet. It's a stainless steel plate that slides into two slots, and it has the proper orifice hole. Some of our custom Interceptors, I'm not sure if the ones we have out there, we started using a section of our plastic trap and we put a plate there. So for the larger units, it acts as a baffle and the flow control. So it's just something that might come up that's a little different, but we'll see if one of those have that out there. So then what comes up a lot with Interceptors is sizing. Page 178, the price book, has how you determine sizing. There's basically two different methods. You see on the page there, there's the fixture unit sizing method with the chart. So that is based off of the amount of flow that you would normally have in a typical size piping. So it gives you like a GPM discharge, and then it'll tell you what intercept you should use. The more common one is up above that where it's labeled sizing. I redid that here for us to kind of go through, just to make sure everyone understands it, see if there's any questions. But all grease interceptors are sized based on the maximum amount of possible flow going through it. And this is all designed to determine what that would be. So I just redid all the calculations that are in the book, tried to label them out where it's a little more easier to understand. So with this one, there's a 3-compartment sink. Each sink each compartment of that sink, the size is 15 inches by 10 inches by 24 inches. So what you do is you calculate what the total volume of that sink is, which is comes out to 3,600 cubic inches. Since there's 3 compartments, you multiply it by 3. So your total cubic inch capacity of all 3 sinks is 10,800 cubic inches. Then what you need to do is convert that volume to gallons. That's just done by dividing that total cubic inch by 231. So once you do that, you have the total gallons of volume in all 3 sinks. And what they do, this is all through PDI, they have you configure it for if all those sinks were 75% full, so you're using 75% of the capacity. So you have 46.75 gallons of total capacity of all the sinks. But calculated by 3 quarters, you come out to 35.06 gallons. So if we wanted all that capacity, 35 gallons, to drain in 1 minute, we would be looking for a 35 GPM unit. Some standards or some codes will say, well, they want a 2-minute drain time, so you can cut this in half. But then once you get the gallons per minute, you can determine what size interceptors needed. So with that, if you look at page 187, it's where our models start. And, the first one is the MIGs, which is MIG series, the most common units. So with that, we know we need 35 gallons per minute. So if we look at the model numbers, and then the it says US GPM, that's the flow capacity of the interceptor, we would need a MIG 6 for that. With the MIG series and the MI-G-L series, all those units come with external flow controls. The MI-G-L series is designed to have a low rough-in to better fit in restricted spaces, whether it's under a sink, if it needs to be buried, and maybe, or if it's on a second floor, they don't want to use a lot of vertical height in the ceiling below. It's less depth than the standard MIG series. Then you can see in the book, it has all the sizes for each model, all the flow, gives you the lids. And then underneath you'll have all your different price options, or prices for different options. And that's pretty consistent through all the different models throughout the book. Page 188, you have the XL MIGs. This is just a continuation of the MIG series. You just get into larger capacity. One thing to look at is, if you look on the MIG series, if you look at the pound, the GPM, and then you look at the capacity pounds, the capacity pounds is always double what the GPM is. And then with the MIGs, the liquid holding capacity is always roughly about the same size as the GPM. So going back to the principles of the interceptor and with the flow, these interceptors are designed on basically 1 minute retention time. Because if it's 50 gallons, the MIG-7, if you have 50 gallons per minute maximum flow going through it, and you have roughly 50 gallon capacity, for that initial 50 gallons to go in, it'll take a minute for all that flow to come in and then go out. So these are normally based on 1 minute capacities. If someone wants a 2 minute capacity and need 50 GPM, then you have to find an interceptor that has 100 gallon capacity, which some codes do state that, 2 or 3 minute retention time. When you get to the XL MIGs, if you look at the same thing, the GPM and capacity, pound capacity, is all the same thing. It's always double, the pound capacity is double what the GPM is. But if you start looking at the liquid holding capacity, you can see where they start to double, nearly double the capacity or the flow. So the larger interceptors have a longer holding time than what the standard MIGs do. And that's just to accommodate because there's such a large flow going through those. And these pages are set up the same way. You have all your dimensions, your pricing for all the different options. And if anyone ever comes, they need a custom interceptor to fit in a certain space, really all you're doing is you're taking the capacity, like your gallons. That is really, if you look in the MIGs or XL MIGs, it's your A, B, and D dimension. Because if you look back at the illustration we did, or I had where it showed the interceptor, that's where all your capacity is. The A, the B, and the D dimension. So that gives you, someone needs, and we get it all the time where someone wants a 100-gallon capacity, but they need to restrict their A and B size because where it's going. So we'll construct the D dimension differently to hold that at the same amount of capacity that's needed. The MIG-SS, it's the same models, or same design as everything as the MIG series. They're just fabricated out of stainless steel, 304 stainless steel. They come with external flow controls, just as the MIG series. MIG-SD, that's the same layout as what you'll see with the MIGs and the one XL MIG because of the MIG-SD8. What these have is a Trough Valve. You can see it in the illustration there on page 189. So when they want to maintenance this, what they could do is they actually open that valve, and that valve is set at the point where all the grease will build, slightly below our water level. So all that's sitting on top of the water as the oil and grease rises, we'll be able to discharge out of that valve. It just makes cleaning a little easier. You'd still have to get in there every once in a while because you're still going to have sludge and sediment that builds up that will need to be cleaned out of there. But it just makes cleaning a little easier, or maintenance a little easier on it. The MIG-SDH, this is similar to the SD, a different setup though. It has a top port on the lid that is normally capped. And when this needs to be maintained, what you'll do is, you see on the outlet there you have the ball valve. So they'll shut that ball valve, remove the drain plug from the lid, connect the hose. We supply a whole clear hose with it. So they disconnect the plug, connect the hose to it. Then what they'll do is they'll run hot water into the interceptor. And as that hot water is entering, you can see in the illustration on page 190, there's the hood on the inside of the interceptor that the hose is connected to. So all your grease has been building up in that area. And as that hot water comes in, it's going to start liquefying that grease and it's going to push it out of the hose. There's nowhere else for the water to go because the shutoff valve is closed. So as the hot water liquefies the grease, it'll start pouring out of that hose. Usually they'll have a bucket there or some type of container to catch it. And they'll keep running it until they see that all the water's coming out clear. You're not getting any more oils or grease in it. And they'll shut off the hot water. You'll disconnect the hose, recap the top, and then open up the ball valve, and it's ready for service again. Any questions on that? Any questions on the grease interceptors? Page 191 shows the cover shrouds. The cover shrouds provide support for the interceptor and adjustability of the inlet and outlet dimensions to match drainage piping where necessary. So we do bolt-ons, which we'll talk about. We can make interceptors with the custom C dimensions, which is the dimension from the top of the interceptor to the center of the inlet and outlet. But if that's really not known exactly what it's going to be, they can use a cover shroud. Inside the cover shroud, you have, there's angles that the interceptor rests on, and you can see on the illustration on page 191, there's multiple vertical holes, so you could adjust the depth of where the interceptor will sit inside the cover shroud. The cover shroud could be set in the slab at the time of pouring, and you could add the interceptor in there afterwards, depending, as long as they box out the void underneath the cover shroud. The shroud is secured and suspended in the slab by the anchoring flanges. Those are the flanges shown on the outside of the interceptor along the A dimension. And then once this is installed and the interceptor is installed, it allows easy access. Even though the top of the interceptor is below your finished floor, this just has pull rings on the lid. You can lift it up, and then you have access to the top of the interceptor. So that's the purpose of a cover shroud. Any questions on that? And next is the oil interceptors. Oil interceptors are designed for use in drain lines where oils and sediment are found. These are normally what you'll see these in parking garages, machine shops, service stations, manufacturing areas. It's more for oil, like mechanical oils, not, cooking oil and stuff like that. Usually that'll be a grease interceptor because it'll separate both the grease and the oil. So these are normally found more in, like for mechanical oils. The oil interceptor is designed to protect against water pollution by preventing oils and sediment and wastewater entering the drain lines. What's real important about these is, we saw in those pipes, that's mostly grease that's solidifying and causing the blockage. Oil really doesn't solidify, so it increases the chances of it getting back into our drinking water system. So that's why it's so important to try and collect these before they get into the waste system. The oil interceptors, the main two are the MIO and MIOHU, page 192 and 193. These come with a draw-off valve, and they allow the intercepted oil to automatically be placed in a storage device. If you look on page 186 on the bottom, it shows a description of the oil draw-off valve. So the elbow and the vertical pipe are inside the interceptor, and they'll set that to a level like it shows here compared to the normal water level inside the interceptor. And what happens with this is, as the oil and stuff build on top, it'll go into this draw-off valve. Now this could either be, with the MIO series, it just has a connection on the outside of interceptor 4. So it could either be direct connected right to some type of tank, retention tank or something like that, or it could be capped, and whenever they want to clean it, they can open that up, draw the oil off that way. With the MIOHU series, it has a built-in integral storage inside the interceptor. So they'll set that draw-off valve, which is in the main part of the interceptor, not the storage area, and whatever oil accumulates on top of the water will go through that draw-off valve into that storage area. So that's the two differences between the MIO and MIOHU. Oil interceptors, they come with vent connections. On page 192, 193, you can see that in the illustrations. There's 2 on each side, so a total of 4 vent connections. These are installed to meet whatever the local codes or guidelines are mandating. There's 4 there. It doesn't mean 4 have to be used. Some standards say you need a cross ventilation, so that's why we put on both sides. Majority of them, they'll say you just need 1 vent connection. They're just regular 3-inch IPS, so they can cap them off, whatever ones they're not using. We put 4 on there to try and meet all of the codes and guidelines throughout the country and across the world. Oil interceptors come standard with a sediment bucket. Back with the grease interceptors, that was an additional option. But since these are normally used in like mechanical type of areas, whether they're car washes or stuff like that, you're going to get a lot of dirt and grit and everything. So they come standard with the sediment bucket, just to try to help make maintaining these a little easier. Sizing and guidelines on the interceptors are found on page 186. The function of an oil interceptor is the same as it was with the grease interceptor. Oils are less dense than water, so they sit on top of water. So it will allow separation of the oil from the water. The interceptor to water exiting the interceptor comes from the bottom. You have the same sludge stop on that. So they're all based on the same principle as the grease interceptors, with the amount of possible maximum amount of flow going into the interceptor, which is the gallons per minute. There are some instructions here on some typical local codes for vehicle servicing, storage, mechanical car washing, and a couple other options. So these are good guidelines to go off of. but it's normally based on what the maximum amount of flow going through it, because you need that same retention time like we talked about with the grease interceptors. And you could see that compared from the GPM to the liquid holding capacity and the oils and the MIOs and MIOHUs. So it gives you a little different, it works off the same principles as grease interceptors. Any questions on the oil interceptors?
Jason, why do we have them?
So that's grease, that's oil. Well, there's a couple other oil interceptors I forgot to mention. Page 194, you have the MIOS. It's kind of like an oil/sediment interceptor. These come with the T1200-4 grades, so they're special duty load rated grades. It has that removable sediment and mud pan. So anything that enters, this would be put in the floor in the middle of a garage or wherever the application is, and anything would drain into this. It would separate the oil and the sediment, and then it would go out that side outlet. With these, if anyone needs with these, they're not based on really the GPM. They're based on the amount of capacity going in there. Because it's such an open top, you can't control the flow. So that's why you'll see these have, they give the holding capacity, but they don't really give a GPM because it's hard to say what the exact amount going through there because we have no control. There's no flow control, to control what's going into those grades. And then the MISO series, which is on page 197. It's an interceptor very similar in design to the MIO series. Includes the Trough Valve, the sediment bucket, has internal flow control. And this one is also based on the capacity rather than the flow going through it. And the reason why this one is because when we talk about the sand interceptor, they're based on how long of a time is needed for whatever type of sand or grits going in there to settle. So when we talk about solid interceptors, we'll talk, that'll make a little more sense. So solid and sediment interceptors. Page 194, kind of run through these here. The first one there is the MyHair. This is normally installed under a sink. Most common is any type of beauty salon where they're washing hair. They have the shampoo stations. So this is designed to catch any hair from running down the drain system and clogging up the whole drain line. Underneath, on the bottom of it, there's a removable cap. So if when it has to be maintenanced, you just unscrew that cap. There's an O-ring seal on it, and inside there's a stainless steel perforated sediment bucket. So they'll remove that, clean it out, put it back in, reapply the cap, make sure the O-ring looks good, so you're not getting any leaks, and reseal it up. These are normally just used per sink. It wouldn't be something where they have 3 or 4 sinks running into one of these. It's a small inlet and outlet pipe, normal size for drain lines on a sink, so it wouldn't be something where they're running like 5 or 6 sinks into one of these units. It should be one per station. The MySolids, there's a few different options there. The MySolid S is a cast iron body. It has an integral sediment bucket and a clean out plug on the top. So with this, when this needs to be maintenance, they'll remove that lid that's shown on the image on page 194. They'll pull out the bucket, clean that out, they put that back, and then if there's any type of maintenance that needs to be done on the line going downstream from this, they have that 1-inch clean out plug they can get to access that. And what happens with this on the illustration is you have your inlet on the left-hand side where it says 2-inch inlet. And then to get to the outlet, the water actually, you can see on the right where that clean out plug is, and it goes all the way down to the bottom of the body. So the water comes in and it goes down and then it comes back up that section and then out the outlet. So any water running through there will run through that stainless steel sediment bucket that's in there. The MySolid LB, that's designed for suspended applications, and it has an access port on the bottom of the interceptor. So like it's shown on page 194, that's how it would be installed, with your inlet outlet running, and then you would have access from underneath it. There's clasps on each side that compress a gasket on there, and the bucket is attached to the lid, or the removable bottom section. So when they pull that out, they're going to get some water coming out. So usually it's a good idea if they open up one or two latches, kind of let it drain out one side, then they could drop the whole thing and clean that out. The MySolid M and L, they're the same design, just for different capacities. They have a top access with removable sediment bucket and a perforated screen located on the, I'm sorry, that's the MySolid TA. They have an internal sediment bucket, and you can see how they have a lower inlet than the outlet. So with sediment, it's the opposite of like we were talking with grease and oil, how that rises to the top of the water. Well, any sediment grit will drop to the bottom. It's more dense than water. So anything that enters this interceptor is going to sink down. So that's why we're taking the water out of the interceptor up high where it's the cleanest. The next page, page 195, we have the MySolid SA. The SA is for side access. So it has this tray on the side. Your inlet is up on top, and your outlet comes out one of the side walls. So it has this tray with clasps that you undo, and you slide the tray out so you can clean it that way. So that tray is perforated, and it's basically just acting like a filter. It's filtering any sediment or anything out of the water, and then the water would fall down and then go out the outlet. The MySolid TA right under that, that's a top access solid interceptor. So you remove this top lid, and then there's a sediment bucket in there. And then on the outlet side, inside the interceptor, there's a perforated screen that catches any debris that hasn't settled yet from continuing down the waistline. These have the GPMs, and if you reference these to the MIG series, they match the same flow. These were designed if someone needs a solid interceptor to be put in front of a grease interceptor, because you want to separate the solid before you separate the grease. That's why they're designed like this. Or if it's just a solid interceptor they're looking for, this could be installed without the grease interceptor. Any questions on any of these? Next one on page 196 is the MySand. The MySand has internal baffles that help separate the sand and includes 2 sediment buckets. There's one sediment bucket located right at the inlet of the interceptor, and then there's one at near like the middle baffle. So there are 2 sediment buckets that come with that, just to try and catch as much debris as possible. The capacity, these don't show any type of gallons per minute. It's all determined by the capacity needed. And this kind of goes back to the MISO, the sand and oil interceptor we were talking about. It needs to be determined how long the particles take to settle in the water to determine the capacity. So if they're using we had one special job, we were using like some type of, I don't know, it was like a gritty plaster type of thing, and they said it was a 30-second retention time needed for that, no matter where it is in the water, to settle. So and they were going to flow 100 gallons a minute into it. So we need at least 30 seconds of 100 gallons per minute to hold there, and then we doubled it to make sure it settles long enough. So it's all determined by how long it takes for those particles to settle. And then once you know that, then you know how much flow is going in there, and then you could determine what the capacity needs to be. So it's really nothing that, you know, you guys are responsible for calculating, but if anyone ever calls and says, how come, you know, the MySand or whatever other ones don't have GPM like the grease and oil, that's the reason, because they have to determine how long it takes for whatever's going in there to settle to let it work properly. The MISD series, that's real similar to the MIOS, page 196, sediment drain. This one has fabricated grates on top, so they're just a light duty, load rated, which is just normal foot traffic. So it's not something that should be installed where, you know, cars or trucks would be going over it or anything like that. If that's something they want, then they should go look at the MIOS series. Some other ones that are kind of like specialized sediment, I guess you could call it. Page 198, 199. You have the MyFish, the MyLint, and the MyRice interceptors. These are all the same design. Just each one has different size perforations. If you look in the illustrations, you'll see that there's those, they have actual perforated baffles. There's 2 sets in each one. So those are replaceable. They just slide in and out like a normal baffle would. So if anyone ever needs replacements, we could give them replacements. We had some jobs where they wanted stainless steel ones. That's not a problem. They have internal flow controls. The MyFish is the only one that has comes standard with a sediment bucket. That's just because of other things, I guess, that could come with MyFish. So, with the fish particles. Any questions on those? The electronic interceptors, page 201 and 202. They're basically, 201 has the grease interceptors, so they're basically just a standard MIG, and then 202 and 203, regular MIO and MIOHU. But what all these have is basically a control system to shut off flow to the interceptor if it's time to clean or maintain the interceptor. So what they have in there is on the inlet side of the interceptor, there's a shutoff valve. Inside the interceptor, there's a float control switch, and then there's a control box that would be mounted somewhere, accessible area. So what happens is the inside switch, it's put into place where it measures the level of the grease or oil. If it's MIO, it's placed inside the interceptor. If it's the MIOHU, it's placed in that holding area or storage area for the oil. And what happens when the level of the oil or grease gets to a certain level, the switch triggers an alarm that's in the control box. There's a red flashing alarm and then a sound alarm. And then it shuts the shutoff valve that's located on the inlet side or before the interceptor. So it's going to shut off any flow in that drain line going into the interceptor. And that'll continue. There's a mute button on the control box if they need to mute the alarm, but it will not reopen until that switch inside is reset when the unit is clean. So it's really, these are sometimes mandated by local codes and guidelines where they want the drain line shut off rather than the possibility of the grease and oils building up an interceptor and then flowing down into the drain system. So That's the whole purpose of those. Any questions? Does that make sense? Last is the bolt-on extensions, page 204. These are basically just a quick way to add length to the C dimension of a standard interceptor. The C dimension is the distance between the center of the inlet outlet to the top of the interceptor. Kind of a different way to do what the cover shrouds do, like we were talking about. So this usually has to be done if they need to adjust or add height to the vertical dimension between the finished elevation and the elevation of the drain pipes within the ground, or whatever elevation, roof or ceiling or anything like that. To install these, the lids are removed from the interceptor, and the bolt-on extension is installed on the interceptor where the lids were. The lids are then placed on the extension. 6-inch or extensions that are 6 inches shorter, they just come with longer bolts, so you can reach the crossbars that were in the interceptor. Anything over 6 inches, the bolt-on extension, like you can see on page 204 on the top picture, it has the crossbars in there. So it'll come with hardware that bolts that extension to the interceptor's crossbars. And then the lid goes on top, and there's crossbars to mount the lids to those crossbars. So just in case someone says they're missing hardware, we ship them with gasket, right? They come with extra roll of gasket, so they can, in case they need to replace what's on the interceptor or anything else. So, but that's it with interceptors. The lid. So here's the cap we were talking about. Here's the MIFAB. As you can see inside there, it just matches the hex shape of the bolt. So this will go on, press onto there, and it'll create a smoother surface rather than have a bolt, less of a tripping hazard. 7 gauge lid. This is what diamond plate is, in case anyone doesn't know. So here's the internals, like we were talking about. So here's your inlet, here's your outlet. Here's your baffle, so it's removable. Your crossbar, here's the cotter pins we were talking about. So they take these out, and they can take the crossbar out. See all the nuts welded on the top like we talked about. So if this was installed, if these nuts rotted out or anything, you'd be able to lift the whole lid out because the bolt would be connected to it. Or if it was on the bottom and this was locked in, there's no way to get it out. So that's that. So here's the deep seal trap. So if you vision this, your water level is going to be at the bottom in the inlet and outlet at all times. So as the water comes in, it hits here, and you can see there's a gap from the baffle to the bottom. The water will flush down there. So this whole area here is you want that as calm as possible, and that's where all your oil and grease are going to separate from the water. And then as water comes in, water needs to push out because your water is always going to keep a constant level. So any water that's going out is going to be taken from the bottom here with the deep seal trap. Now this is a real small MIG, so it doesn't have the sludge stopper. The deep seal or the deep seal trap and the gas stopper, that's what this plug is. So your drain line is connecting to here, and you can see inside there's this wall here that separates where actually the flow's coming out of. So it creates a water seal. So there's nowhere for gases to come up into the interceptor. It all stops right here. The black plug is here, so if they ever need to maintenance the lines downstream with a snake or clog something, they pull this cap off, and they'll have access to all the way down there. I'll grab and show you guys a MIGAT or MIG trap. It's a plastic one we started using, and it has 2 screws or 2 nuts that you undo and you take the whole trap out, then you have access to the line. But that plastic unit does the same thing that the steel one does. Here's the flow control. So I don't want to unscrew, you guys saw the pictures of it. Well, so here's your vent connection. This would go right in line somewhere along before the interceptor, your vent connection. And then you could see there's your orifice hole to control the amount of flow going through it. So that'll you know, make sure that there's not too much water going through, too much water running through, and won't give it enough time for separation. So that controls and maintains the amount of flow going through it. And that's all based on the calculations we did, the size an interceptor needed, stuff like that. Same lid, same bolts, same type of crossbar setup. This one's pretty custom, but it's got all the stuff in there. So, Francis, where's the inlet?
The inlet would be here because your orifice.
All right, nice.
Also label.
Oh. Can't read from this angle.
So you have your crossbar held in the same way by the cotter pins. So you can take those out. Don't get nervous. These are your vent connections on the side, your inlet, your outlet. This is an HU. So you can see, here's the main interceptor part. Here's the holding area. There's the draw-off valve. This is fully welded, so it's a totally separate compartment. What else do I want to look at? So here's an internal flow control. This one's pretty outrageous because it's so custom. So this one's pretty crazy because they want a huge inlet and outlet, but it's such a small interceptor. That's why the hole's so small. But so with the external one, how we had the hole in the FLC. This is how we control the flow with this one. So it controls the flow as it enters the interceptor. Here's your baffle. The oil ones don't have a removable baffle. So this one, the water comes in, hits this, and that tries to create a calm area here. Here's your sediment bucket. We say comes standard with oil interceptors. So here's a draw-off valve. So when we're looking in the book, what they'll do is they'll fill this up to, you know, normal operating water height, and then they have this where you could adjust the height of this. So you could lower this or raise it. So you follow those instructions that were in the book of where to set this compared to the water level. So whatever builds on top of that water level will go into here, and then this drains right into the holding compartment. Deep seal trap, same setup as the grease one we looked at. Your deep seal trap takes water from the bottom. This one has a sludge stopper on the bottom. So anything that gets past the sediment bucket will, you know, catch that to try and eliminate this from getting clogged, because that's where your outlet is coming from. Same as your plug, so if they ever have to maintenance the line, they got access to it there. Then the last thing, this is just a bolt-on extension. So you can see this would drop into a normal interceptor. You take the lids out, you put this in where the lids are, so it's fit right on the same gasket, and then they're supplied with the gasket material that will go around here. Now this one's probably 6 inches, so it comes with longer bolts that would bolt directly into the crossbars that are in the interceptor. Taller, you'd see more sets of crossbars and crossbars.
Those are included too.
Yeah, those come. There it is. So this has longer bolts, so it'll reach down into where the crossbars are. Otherwise, that's it. Any questions?